All right. Well, thank you. Thanks to those who reminded me to um, post the answer of this particular practice test because I got too much stuff to do on Friday and forgot about it. So anyway, let's get started with this one. Just like with the other one, the carry flag is actually, in this case, the borrow flag carries a lot of information because if we know that this is T7, so if T7 is a 0, so we know that for bit 6, none of the subtraction is resulting in a borrow. And as a result, this bit over here, this Q6, has to be a 1, because if it were a 0, that would have given us a borrow of 1 for T7. So now that this one is a 1, then we already know that this D is a 0 because that's the exclusive OR between the Q and the T bits. Because this is a 1, and yet we do not have a borrow over here. So that means the only way we can make that happen is to have a 1 minus 0. So all of this has to do with constraints of the equations that we have already talked about in binary subtraction. For the next column, okay, because this is a 1, so we know there is a borrow. But we know that you cannot get a borrow from something minus 0. But so that means the only borrow that can happen is from this Q5 minus this T5. And the only way to end up with a borrow over here is to have a 0 minus 1. So we have a 0 minus 1 here, which has a result of a 1. But in order to get a 0 here, we already know this is 0, so that means we have to have a 0 minus 0. So I'm not writing down any of the rationale. So I'm just I'm just talking about it. So the proper answer, when you submit the answer, you actually have to write down the answer. I'm just talking about the answer, but you kind of have to turn all of those into words in the document. All right, so let's go back to this one. So once again, we do have a borrow of 1, and no matter what you subtract from a 1, you cannot end up with a borrow. So the borrow has to come from, once again, your Q4 minus T4, and the only way to end up with a borrow in this case is 0 minus 1, which has a result of 1. But to end up with a 1, because of the 1 minus this question mark, so this question mark has to be a 1 in this case. So now we look at this one, and I think, okay, we haven't exactly seen this scenario, but it's very similar in the previous one. So we know that the subtraction of whatever this bit is minus this 0 cannot give us a borrow of 1 over here. So that means the borrow of 1 has got to be coming from x3 minus y3. And the only way to have a borrow is to have a 0 minus 1. So that means we have a 0 minus 1, which has a result of 1 and a borrow of 1, which is already here. And then we have a 1 minus a 0 being a 1 here. There's a borrow of 0 over here, and we already see there's a 1 here. So if we have x minus 1 not ending up with a borrow, the only way to make that happen is to have a 1 over here, which means this has to be a 0. And there's only one value that you can subtract from a 0 and not ending up with a borrow of 1, and that would be just 0 itself. 0 minus 0 is 0 down here. So now we have this 0, and you can see that I think we might have seen this scenario already. So let's just kind of work out the entire thing. So this 0 means we do not have a borrow from bit 1. So that means whatever the 1 is being subtracted from has to be a 1, not to end up with a borrow. And in order for this to be a 1, and in order for this subtraction of x1 minus y1 not to end up with a borrow, but end up with a 1, is to have a 1 minus a 0. And then we have a 0 down here. And once again, we do have a borrow, and we know that it's not coming from Q0 minus T0, so it has to be coming from X0 minus Y0. And the only way to end up with a borrow of 1 in binary is to have a 0 minus 1, which ends up with a 1. 1 minus 0 is a 1. So that's how we work out every single bit in this particular subtraction. And we also want to work out the borrow bit, the overflow, and the sign bit. And also, I think the L, yep, and the L flag. All right, so to work those out, I'll just kind of put the answer down here. All right, there we go. So the borrow bit is the 0 because it is already given to you in the question itself. This is the overall borrow bit after the subtraction. The sign bit is also easy. The sign bit is the most significant bit of the difference, which is this bit over here. So the sign bit is a 0. The overflow bit is the overflow bit is this bit and not this and not this, or not this bit and this bit and this bit over here. So in this case, it is indeed a 1 because the first conjunction is true already because it is the non-negated most significant bit of x, and the negation of the most significant bit of y, and the negation of the most significant bit of difference. And that conjunction is given us a 1 already. The L flag is the sign flag exclusive OR with the O flag. And in this case, it is 0 exclusive OR with 1, which is a 1 in this case. So if we choose to interpret x as a signed value, y as a signed value, and d as a signed value, then x is less than y, which makes sense because x has the sign flag being a 1 and y does not have the sign flag being a 1. So that means x is representing a negative value and y is representing a non-negative value. So we can basically say that any negative value is always less than any non-negative value. So the L flag being a 1 does make sense. All right, so let's move on to question number 2. So in this particular question number 2, let's work out the values of each side of the equation. So on the left-hand side, we have 2 times 5 to the power of 0 plus question mark. We'll call the question mark x, okay? So let me go back here and just kind of modify this slightly. We'll call this x and we'll call this y, okay? So we have x times 5, to the power of 1 plus 0 times 5 to the power of 2 plus 2 times 5 to the power of 3. 0, 1, 2, 3. Yep, okay, that's correct. So after we work out all the constants, we end up with 5x plus so this 2 is really just a 2, and then this 2 here is 2 times 5 cubed, and 5 squared is 25, and 25 times 5 is 125, and we have 2 of those, so we have a 250 as a constant. On the right hand side, which is the base 6 number, we have 4 times 6 to the power of 0 plus y times 6 to the power of 1 plus 1 times 6 to the power of 2 plus 1 times 6 to the power of 3. So when we work out all the constants and whatnot, we have 6y, okay, 6y plus, oh, okay, I just messed up here because I forgot to add the other constant, which is the 2. So we have 252. So in the case of the 6, we have the 6y plus the 4 plus a 36 plus a 36 times 6. Okay, we'll just write it out, 36 times 6. So if you use a calculator, you can figure out what is 36 times 6. I think it's 216. Yep, so that makes sense. So we have 6y plus 4. Okay, so that adds up to 40 plus 216. and that would make it 6y plus 256. Well, certainly looks that way. All right, so they are the same. So we have 5x plus 252 to 5x plus 252 equaling to 6y plus 256. So once we take care of the constants, then we have 5x equals to, oh, that doesn't seem to make sense. Okay, I must have messed up in the math somewhere. Yeah, that doesn't make sense. Okay, but I'm just going to go with the math here, and then I'll tell you why it doesn't make any sense. So that's a 4 left over. So I definitely messed up my math somewhere. So there's a 2 and 2 of 1, and then we have 5, 25, and 135. So 252 seems to be correct in this case. And then in the base 6 number, we have the 4, and then 4 of 1, y of 6, 1 of 36, that is correct, and 1 of 36 times 6. So that means I must have messed up my calculation of what is 36 times 6. Let me just go off screen here and give it a try. 36 times 6 is 216. That is correct. Huh. That is very strange because 5x. Oh, okay, that may work out after all. Okay, never mind. Because x has a range of from 0 to 4, and then y has a range from 0 to 5. Okay, but we can still choose a combination of 5x, x and the y, so that this equality works out. So we'll write down the constraint of x is at least 0, and it is at the most 4. And then y is at least 0, but it is at the most 5. So we just have to pick from one of these, let's see, 5 times 6, which is 30, 30 combinations of values of x and y to make this work. You can use a spreadsheet to do it. The only requirement is if you did do that, you have to copy and paste a spreadsheet into this document to explain how you got to the answer. We can also just try to work out the math here, okay? So because based on the constraint, there should be only one value of x and one value of y that makes this work, x and y being integers. So we know x is going to be greater than y because otherwise the math just doesn't work out. So that is a pretty big constraint. So if y is so we know that, oh, okay. Okay, so let's work with possible y's first, okay? If y is a 0, then we cannot find the x to make it work, because if y is a 0, then we have 4 on this side. So now we try y being a 1, then we end up with 6 plus 4, which works out pretty nicely, okay? So we can say when y equals to 1, then 6y plus 1 equals to 10, which turns out to be equaling to 5 times 2. So x equals to 2. Okay, so that works out. So the answer is x is 2, which means this digit here is a 2, and y is 1, which means this digit here is a 1. Okay, so I'll just go ahead and write the entire answer here, which is 2, 0, x is 2. So x 0, x 2022 in base 5 is 1114 in base 6. There we go. So now we move on to question number 3. So once again, we have to resolve the unknown bits, based on constraints. So we'll go ahead and start with this one here. Okay, this is an easy one because we know the Q is the exclusive OR between not X and Y. So we know this has to be a 1, which means this has to be a 0. And then we also know that the sum is the exclusive OR between the Q and the K. So this one has to be a 1. So this one is far easier to do than question number 1 because each column is more or less independent to other columns. So once again, we got a 1 here, which means this has to be a 1, this has to be a 0. This is a question mark, and this is a question mark. But we can resolve that because we know there's a carry of 0 to the next column. And the only thing you can add to 1 to not trigger a carry of 1 is to add a 0 to it. So that's a 0, this is a 1. And then we have something add plus 0 equals to 0. So this has to be a 0. And then this has to be a 1. And this has to be a 0 because that's the exclusive OR between the Q and the K. Same thing over here. And same thing over here. Okay, so these two columns work out using the very same mechanics. And I think this one works out not exactly the same. But we can work this out because we know that there's a carry of 0 in bit 3. So that means whatever we're adding to this one has to be a 0 because if we add 1 to 1, we have a carry of 1. So now we know this is a 1. And the only thing can add to 0 to get a 0 is 0 itself. And then the bitwise not of 0 is a 1. And now we move on to this column. And this time we do have a carry of 1 in bit 2. And the only one of the two, you can only the second one has a chance to generate a carry of 1 because only 1 plus 1 has a carry of 1. And the only thing you can add to 0 to get to 1 is 1 itself. Okay. And this is the bitwise not of the 1, which means it's a 0. And then 1 plus 1 has a carry of 1, which is already taken care of here. But the partial sum, or the 1-bit sum of 1 plus 1 is 0. Okay, sorry about that. The 0. And now we're down to the least significant bit. So with the least significant bit, we do end up with a carry of 1, okay, and the only chance to get a carry of 1 is 1 plus 1, so we have a 1 here and a 0 up here. 1 plus 1 has a partial sum of 0, and then 0 plus 0 is a 0. So that's how we work this out. And once again, I am verbally, or using my voice to explain. In your answer, you're going to have to write it down, okay? And also quote the definitions and expressions. All right, so now it says, step by step, determine the values represented by X and also by S. In other words, we want to know what is the value represented by this pattern and what is the value represented by this pattern here, okay? So let's go ahead and work on that. And I'm going to do it like this. Okay, so X is 0 of 1 plus 1 plus 0 of 2 plus 1 of 4 plus 1 of 8 plus 1 of 16 plus 0 of 32 and 0 of negative 64 because we are looking at a signed value. So that's why the most significant bit, which is bit 6 in this case, is representing how many negative 64s we have. So now we just have to add up all of these things. We got 1, 4, 1, 8, 1, 16 basically. So that's 12 plus 16, which is negative, excuse me, which is 28. Okay, not negative 28, but just 28. On the other hand, the sum is going to be 0 of 1, 0 of 2, 1 of 4, 0 of 8, 0 of 16, 1 of 32, and 1 of negative 64. So we just have to kind of add up these numbers, these particular values. So we got a 36 minus 64 in this case. And the result of this subtraction is 28, which is not surprising, right? It's negative 28. So that's how, but the important part is not so much this particular value here. The important part is how do we get there, okay? And this is basically how we got there. And of this particular expression, the most important part is the most significant bit, which is this 0, which is corresponding to this 0 over here, is multiplied by negative 64. And this 1, which is the most significant bit, which is the same as this bit over here, is multiplied by negative 64 because we need to look at the signed interpretation of the bit pattern. So that's question number 3. And now we move on to question number 4. All right, so the question number 4 in this case, we'll answer these one by one. So in order for both of these conjunctions to be 0 is rather easy because we just need to have one of them being a 0. So in this case, if we guarantee that P8 is a 0, then both of them would be 0 to begin. That's the answer. So we can say P8 equals to 0 implies, and this is carry log ahead. Okay, so that implies the disjunction or the OR between X and Y for bit 8 is a 0. But if you want the OR to be a 0, that means each component has to be a 0. So if I explain this fully, then we have x8 plus y8 being a 0, which then implies x8 is a 0, y8 is a 0. And that is sufficient to make both of these conjunctions zeros. We do not need to know anything about the other bits of x and y. Okay, in the second case, we want one of them to be a 1 and the other one to be a 0. Okay, but in order for this conjunction to be a 1, we need every single one of these to be a 1. And of all of these terms, we know that P5, P6, P7, P8 are P5, P6, P7, P8 are being shared with the other term. So we do not really have a choice here. So we basically say P5 to P8 equal to 1s. And the only differentiator here is G2P3 also has to be a 1. Okay, so we also say G2P and P3 also equal to 1. But at the same time, we want G4 to be a 0. Okay, and now we want to look at this and go, okay, so what does that tell us about the values of x and y? Okay, so we now say this implies, okay, so this implies for P5 to P8, that's easy because it's a disjunction. So that means let me see what the question is asking. Okay, whether it's possible, okay, if it is possible, specify a bit pattern of x and y that makes the combination happen. So in this case, I just have to find one single description to make it happen. Okay, so in this case, we'll say all other bits do not matter. Okay, so that means they can be zeros or ones. You pick whatever you want. In this case, we one example to make it happen is to have p x bit 5, bit 8 down to 5 being 1. So there will be 4 ones in this case because it's bits 8, 7, 6, 5. The corresponding bits of y would then be either ones or zeros. It doesn't really matter. Okay, so you can make them all ones too. So that will make this portion happen. Okay, now we need to look at bits 2 and 3, but there's also 4 is here. Oh, okay, so I forgot one of them. Okay, so P4 is also a 1. So if P4 also needs to be a 1, then we can just extend. Oh, okay, so this is the tricky part. The tricky part is we want P4 to be a 1 and yet G4 to be a 0. So that means P X4, one of them has to be a 0, the other one has to be a 1. Because we need the conjunction to be a 0, but we want the disjunction to be a 1. So that's how we can work out bit 4. And then for bit 2 and 3, we need the conjunction of bit 2 to be a 1. So that means that both of them need to be 1s. So we want to extend this down to that. Okay, so this one is yet to be determined, but we know this one has to be a 1. And once again, this one, which is bit 3, we are not interested in that just yet, but bit 2 has to be a 1. So now we work on bit 3. So the only requirement of bit 3 is the p term has to be a 1. The p term is the disjunction of the corresponding bits in x and y. So once again, we just need at least one of them to be a 1. Okay, so we can have a 0 here, we can have a 1 here, it doesn't really matter. All right, so that will make the second case happen. Now we need the third case. So in order for this to happen, we can reuse some of the rationale from before. So we can say, P5 to P8, they need to be 1s. And then in this case, G4 needs to be a 1 because G4 is the extra term in the conjunction that needs to be a 1. And then we need G2 times P3 times P4 to be a 0. Okay, so that's kind of the requirement. And this implies, this can be achieved by, and the other one should be just saying that too, because there's a huge difference between implying, because implies means, that is going to be the only bit pattern. Can be achieved by simply means this can be one of the many bit patterns that can do the trick. Okay, so we'll specify x first. The most significant bits of x, from bit 5 to bit 8, we just say, okay, let's make all those 1s because we just want to make sure that all the p terms, p5 to p8, being 1s. So that's easy. 1, 2, 3, 4. So those 4 bits are 1s. And then the same thing for y. Okay, 1, 2, 3, 4. There we go. So now we need to work with bit 4. So bit 4 is a little bit tricky. Well, it's not really that tricky because we need G4 to be a 1. So that means it needs to be a 1 in both numbers, in both x and y. So that takes care of bit 4. Now we need to look at bit 3. Bit 3 really can be anything we want it to be because we just need to make sure that between G2 and P3, one of them is a 0. Okay, so you can make P3 0, you can make G2 0. It doesn't matter which way. So in this case, I'm just going to make P3 a non-zero, and then we'll make G2 a 0. To make G2 0, there are like 3 ways to make it because we just need at least 1 0 between the x and the y. But 0 0 would definitely do it, right? Because 0 and 0 is 0. So once again, this is bit 2, this is bit 3, 4, 5, 6, 7, and bit 8. So now we have specified the entire bit pattern for x and y. And this one is the super easy one because in order for both conjunctions to be 1, you just have to make all of those bits 1s. Okay, so in this case, we need G2, P3, P4 to be a 1. We need G4 to be a 1. And we need P5, P6, P7, and P8 to be 1s. In other words, we want every single term to be a 1. Can be achieved by, let's just make everything a 1 in this case. Okay, so we have, let's see, 7 bits to specify here. So we have 1, 2, 3, 4, 5, 6, 7. And then the other one is the same, y 8 down to 2. It's also 1, 2, 3, 4, 5, 6, 7. There we go. And the question is a little bit specific about making sure things are of the right base. So we'll just kind of add base 2 to every single one of these. If you know how to use subscript, you can definitely use subscript too. I believe there's a shortcut key to do it. But I'm not using Google Doc right now. I'm using LibreOffice because because it's an extra step to have to upload it to Google Doc. So that's it. Okay, so that would be the answer of the extra question that I sent you guys. I'll post this YouTube, right now, and then post the link in Discord so that you guys can now watch it and compare my answer to yours.